In this video, I'm going to show you how to do completing the square. I'm going to show you first how to find the quadratic in vertex or graphing form, and then I will show you how to use completing the square to solve the quadratic. So to start, we move this constant term to the other side. So that's negative 52 plus y equals w squared plus 28w. And so now I want to figure out how to make this a perfect square trinomial. So to do that, I am going to kind of figure it out using this generic rectangle. That I would put w squared there, and then I cut the 28w in half, and so that's 14w and 14w. So then I think about what my dimensions would be to get these. So this rectangle would have to be w times w, and then if there's a w here, this one has to be 14, and this one has to be 14. And so then I multiply 14 times 14 to get that square, which would be 196. So I have to add 196 to both sides of my equation because I need to keep my equation with the same value. And then what I do next is combine like terms on this side. So 196 minus 52 is 144. And then this is now a perfect square trinomial, and the dimensions are this. So I can just rewrite this as area written as a sum, and now I'll rewrite it as the area written as a product. Okay, and then the last step is to move the 144 to the other side. So I get y equals w plus 14 squared minus 144. So the vertex of this parabola is always, you take the opposite of what's in the parentheses, so that's negative 14 for the x value, and then the y value is always just what this says, exactly as it says, so 144. Also, to find the y-intercept at the same time, you can do a couple things. Remember, the y-intercept is where x is 0, so I can plug in 0 for x up here. Oh, sorry, this particular equation is with w's, so where w is 0. And so I would put in 0 there. Everywhere I see a w, and those two terms disappear. So I know that my y-intercept is 0, 52. And then the other way you can do it is using the vertex form, plugging in 0 here, and then you would do 14 squared, which is 196, subtract 144, and you would get 52 as well. So that's the other way to find the y-intercept if you're given vertex form. Now we're going to use completing the square to solve this quadratic. And remember, solving it means to find the x-intercepts, or in this case, since they've given us w's, the w-intercepts. And so this problem, normally to solve, remember to solve, that means to find the x-intercepts, in that place y is 0. So your problem, you would substitute 0 in for y. And then you do all of the same stuff you already did, but you are at this point, you wouldn't move it back over because you want to now solve it. Now remember, the y is 0 because we're solving for the intercepts. So let me rewrite with that being 0. You get 144 equals w plus 14 squared. Okay, so now you can just solve this. How you undo something that's been squared, you take the square root of both sides, and the square root of 144 is 12, and the square root of something that's been squared is w plus 14, but there is also another number that if you multiply it by itself, you get 144, and that would be negative 12. Negative 12 times negative 12 is also 144. So that's how you get your two roots. And then you just move the 14 over, and this one is negative 2, and this one would be negative 26. Just combining the negative 14 with the negative 12. So your roots would be negative 2, 0, and negative 26, 0. When it just says to solve, you can actually leave your answer right here in that step if you want. But if it specifically says state the x-intercepts, you better write them as a coordinate point.